So the next section is reduction involving numerical and special angles, grade 11. So now let's not forget about our special angles, which we bring through from grade 10, and those are 30, 45, and 60. Let's quickly draw our triangles. Okay, these need to be committed to memory, so you have to learn them and remember them. So if we do the 60, 31, I always do it in the same triangle. The longest side, the hypotenuse, is 2. Next to 30 is root 3. And then the third side is 1. Now the other one is our 45, 45. So that's an isosceles triangle. 45 and 45. And that is 1, 1, and root 2. If you prefer to use your Casio, your calculator, then you can, instead of using 1, 1, and root 2, you can use root 2, and 2. Either is fine. So let's look at a few examples now, bringing through our reduction and then how we use the special angle. So let's look at number 1 first. Calculate the value of each of the following expressions without a calculator. Okay, we need to keep that in mind. We do sometimes use it, but we need to show all our workings. So the first one is sine of 240. Now, before we can even use our special angles, we need to use our reduction formula here. So remember the questions we ask: what quadrant do we work in, and what's the acute angle? So 240 takes us to the third quadrant. Sine is negative, and then to work out the acute angle, remember in this it's 180 plus what gives us 240, and it's 180 plus 60. Then the sine of 60 is going to be opposite over hypotenuse, which is root 3 over 2. I'm going to move quite quickly through these and then get to more difficult ones sooner. So then we're going to now move on to number B. And here we reduce 330 and we reduce 135. 330 takes us through to the fourth quadrant. Cos is positive there, and my acute angle is 30. Then we look at 135, which takes us to the second quadrant. Tan is negative there, so it's negative tan, and the acute angle is 180 minus 135, and that gives me my acute angle of 45. What is cos of 30? Cos of 30 is going to be adjacent over hypotenuse, and tan of 45 is going to be opposite over adjacent, which is 1. So in terms of layout, which again is very important, the first step we reduce, then we replace it with our special angles, and then we get the answer. Let's do a third one together, number C. Now this has got squares in it. Let's see how that affects things. Remember, just an aside over here, if we have sine squared of 315 degrees, that's exactly the same as having the sine of 135 and then squaring the answer. That is exactly the same thing. So first thing we need to do here once again is reduce. Reduce, reuse, recycle. Okay, so we're reducing here, our reduction formula. So 315, and I always show this working. It just makes sense. So 315 is in the fourth quadrant. Sine is negative in the fourth quadrant, and my acute angle is going to be 360 minus 315, which is 45 degrees. So this becomes negative sine 45 degrees. But remember, it's squared. So I'm going to put my result inside a bracket and square it. Minus 1. Then we move to the denominator. 210 takes me to the third quadrant. Sine is negative in the third quadrant. 210 is going to be 180 plus my acute angle, which is going to be 30. Don't forget, it's squared. Now, what is the effect of the square on this minus? A minus times a minus is a plus. So in fact, whenever we square a negative, we just drop the minus. So it's not necessary to even show this minus, but I like to show it so that we can remember in the next step that it is negative. In the next step it just goes away. So now we're actually looking for the sine of 45. Sine of 45, I'm going to use my Casio, my calculator, and I'm going to go sine of 45, which gives me root 2 over 2. So I'm actually going to change this here. I'm going to change this to root 2, 2. Now we're going to have this here, and it's going to be sine of 45 is going to be, I seem to love threes. It's going to be root 2 over 2 squared minus 1. Denominator sine of 30. Sine of 30 is going to be a half. Squared. I'm just ignoring the minuses because when you square them they fall away. Then in the next step, this will be at the top, and there's no harm in just using your calculator here, but I'm going to do so. You square the top, square the bottom, so that's just going to be 2 over 4 minus 1 all over 1/4. Now there's absolutely no need to show the working in the next step, so it's just going to be, your final answer is going to be minus 2. And I'm just doing that all on my Casio. As long as we show the following steps, we show the reduction line, we show the replacement of the special angles with the actual ratios, and then from there we could actually just go straight to the answer. But it's possibly a bit better to show one extra step of working, and then we can use our Casio, our calculator, straight to the answer. Okay, let's keep moving. Calculate the value of each of the following expressions without the use of a calculator. Okay, very important that the first thing we do is we reduce. So 110, second quadrant, sine is positive, and 180 minus 110 is 70. I'm going to move a little bit quicker. 200 takes me to here, cos is negative. 180 to 200 is 20. Plus 315 takes me to the fourth quadrant, and that is going to be, sine is negative. Let's put it in brackets and we square it. 45 if I reduce it. Okay, just one little comment here is you can see I've put these in brackets here. And the reason why is because it's going to affect my signs, whether they're going to be positive or negative. So let's just stick with the moment. We've got sine 70. Plus times a minus is a minus, cos of 20. This whole thing becomes positive, so plus times a plus is a plus. And this is sine of 45 squared. So now you look at this and you think, okay, this one here is a special angle, so that's no problem. But now we've got an interesting thing here, because I'm sure this can reduce further. And then I hope you've spotted that these here are co-ratios, because 70 and 90 are complementary angles and sine and cos are co-ratios. So I can change this to be the cos of 20 degrees, because sine and cos are co-functions and 70 and 20 are complementary angles. So sine of 70 can be replaced with the cos of 20 minus cos of 20, and then you can see they will cancel. Let's quickly have a look what sine of 45 is. So you've already drawn your triangle. I'm just going to redraw it here. So sine of 45 is going to be root 2 over 2 squared. So now cos of 20 minus cos of 20 is gone. My final answer is going to be 2 over 4, which is a half. Isn't that fantastic? Okay, let's just quickly recap here. We've reduced in that line. We've spotted something here, and so we've used our co-ratios here. Here we've reduced. There we've used special angles. And then we've simplified. Okay, so that generally is going to be the case. We're going to reduce, see what we need to use, co-ratios, etc., special angles, and then simplify. Let's do another example, the last one. Okay. First step, reduce. 240, 270, 240 is there. Tan is positive. So this becomes the tan of 60. Next one, minus 280. Don't forget a negative is this way. So that's 7. So it takes me all the way around to the first quadrant, and sine is positive there. So it becomes positive. Now the question is, what's my acute angle? And because I'm reducing, I want to know what that angle is there. So if I just recap here quickly, all the way around to there is 280. But I want the acute angle because it needs to be in terms of my horizontal line. So that, what is that there? It's going to be 360 minus 280. And that will be my acute angle. So what is that? It's 80, hey? So that's going to be 80. Underneath, we have minus 30. That's also going to take me into the fourth quadrant because it's negative and tan is negative there. 370. 370 is going to go 360 is all the way around up back to the first quadrant, and cos is positive there. And 360, I'm adding on 10, so my acute angle is 10. Nothing can cancel here. That's a problem. My final answer will have a negative though, because a plus divided by minus is a plus. And I'm looking and I'm thinking, but I am beginning to notice. What am I noticing? Okay, what I am noticing is that this is a special angle, that's a special angle, and I am noticing that these are co-functions. So I'm going to use my knowledge there. So I'm quickly going to draw my triangle. Remember, you don't have to draw this triangle every single time. It's just that I'm working with it here. So tan of 60. Oh no, what am I doing? Tan is opposite over adjacent, so it's root 3 over 1. This time I'm going to change sign to be cos of 10. And the cos of the 10 at the bottom can stay. Remember, because I can do that, because 80 and 10 are complementary angles. They add up to 90. And sine changes to cos or cos to sine. And then at the bottom here, I want to know, why have I made that minus? That must go. Tan of 30 is opposite over adjacent, so it's 1 over root 3. Now let's finish this off. Plus divided by minus is a minus. That goes, and root 3, I'm going to do that on my Casio, divided by 1 over root 3 is going to give me 3. What do you know? What a lovely answer. And they often work out to be really lovely answers. Good. Nice challenge. Once you know your theory, you've built on your theory. And now on page 118, there's a few to practice. I'm going to ask you to do this one, D. Let's do H, G. Let's give you another one. Which one? Shall we do this one here? And one more. This one. Okay, so if you can do those 5, D, G, H, I, and K. Good luck, grade 11s. You should be A for away.